Welcome to this discussion on simple interest and compound interest. The concept of interest is a concept that comes in the domain of finance. If you are a person who has taken a loan at some point in time, the concept of interest and the way in which it is computed will be familiar to you. It is a concept that everyone should know because sometime or the other we will come across a situation where we need external funds to finance our requirements. It may be to fund our desire to have a bike or a car, or to finance our overseas education, or to fulfill our dream of an own house, or even to start a new business of our own. The idea of interest has been in existence for more than 4,000 years now. The idea is simple. Let me illustrate with an example. Let us say you are in need of 5 lakh rupees to fund your planned overseas education. Let us assume that you do not have the required money with you. Neither do your parents. What are the options available to you? Maybe you can forget the idea of overseas education altogether. Or you can think of ways to arrange the funds to fulfill your desire. Who will give the money? You may turn to your relatives or friends who could support. If there is no one of that kind, you can look for formal avenues from where you could get the funds, like banks, money lenders, etc. The person who gives the money is called the lender, and you, who borrows the money, is the borrower. Why should a lender give you the money? Look at it from the lender's perspective. The lender can do a lot of things with the money that he gives you. He could put this into some money generating activity which we call investment. Or he could simply spend the money to enjoy the various luxuries of life. Instead, he is lending the money to you. Look at it from the borrower's or your perspective. If you were to earn this money through your work, it would have taken quite some time and you would have to wait till then to enjoy the benefits of the money. The opportunity to study abroad may not be available at that point in time. The lender gives you the money and helps you fulfill your desire. Of course, the lender expects the borrower to pay back the loan amount. Over and above that, the lender would want a fee for foregoing his money for your benefit. Then there is the problem of inflation or rise in prices. That is, the lender may not be able to buy the goods that he could have bought today if he were to get back the same amount from the borrower 2 or 3 years later, because the price of goods would have increased by then. The lender is also taking a risk because there is a possibility of the borrower not paying back at all. So definitely, there should be a fee for the loan, and the fee paid by the borrower to the lender for the usage of his money is called the interest. Similarly, when you put your hard-earned money in the bank makes use of the money till you take it back, and it pays you an interest for the usage of the money. If you borrow a larger amount, the lender would expect a larger fee than what he would have got from a smaller loan. So the interest amount would depend on the amount borrowed. Larger the borrowing, larger the interest amount. If you, the borrower, keeps the money with you for a longer period, the lender would want a larger fee from you. So the interest amount will also depend on the time duration. If the money is scarce to come by, then the fee for foregoing the amount would be higher. On the other side, if there is surplus money everywhere, the money is easy to come by, then the fee for the loan would be lower. This is captured in a term that we commonly call the interest rate. If the interest rate is given as 10% per annum, What it means is the fee is rupees 10 for every 100 rupees for 1 year period. If the interest rate is given as 5% per month, it means that the fee is rupees 5 per 100 rupees for a period of 1 month. Usually, interest rate is mentioned for a period of 1 year, and if nothing is specified about the period, we take it as 1 year. Finally, the interest amount will also depend on the method of computation of interest and the frequency of computation of interest. We shall look at these two aspects in detail a bit later. Now, refer to the question Q1. A very simple situation to introduce you to the concept of interest calculation is given in the question Q1. There, we have two people, Xavier and Yasser. Xavier takes a loan of rupees 1 lakh from Yasser. Xavier is the borrower and Yasser the lender. The period for which the money is borrowed is 1 year and the interest rate is 10%. We need to find out the amount that Xavier should give back to Yasser at the end of the year. At the end of the loan period, Xavier will have to give back the loan amount, which we call the principal amount, and the interest or the fee for using the money for the period. As we saw earlier, the more the money, the more the fee. It will also depend on the rate or the fee charged per unit amount for the borrowing. And more the duration, the more the fee. Thus, interest is given by interest equals principal into rate into number of years. Here, principal amount or the amount borrowed is rupees 1 lakh. Rate of interest or the fee per unit amount for the year is 10%. That means the fee is rupees 10 for every 100 rupees for a year. Or if you convert it into decimal value, 10% is equal to 0.10. That is, the fee is 0.10 rupees for each rupee loan for a period of 1 year. In this case, the duration of the loan is 1 year. Thus, the interest equals 1 lakh into 0.10 into 1, which is rupees 10,000. So the total amount that Xavier has to give back to Yasser will be equal to rupees 1 lakh, the principal amount, plus rupees 10,000, the interest, that is a total of 1 lakh 10,000 rupees. Look at the question Q2 given in the slide. Here, Rashmi borrowed a sum from Sushma for a period of 2 years. And Sushma wants a 10% interest and that to be computed annually. The situation is different from the previous question in the sense that the period of 2 years for which the amount is taken and the period of computation of interest, which is 1 year, are not the same. This introduces some confusion with respect to the treatment of interest that accumulates at the end of the first year. There are two possible scenarios here. In the first scenario, the interest is calculated on the original principal amount only. The interest accumulated at the end of the first year is not taken into account while computing the interest for the second year. Calculating the interest in this manner, where the principal amount only is considered when calculating the interest, is called a simple interest approach. In the second scenario, the interest for the second year is calculated on the sum of the original principal and the accumulated interest for the first year. Now, look at it from the point of view of Sushma, the lender who gave the money to Rashmi. If Rashmi were to pay back the amount after a year, then Sushma would have had the original principal plus the accumulated interest with her. And Sushma can give this increased amount to a borrower for the next year. This would have enabled her to get more interest than what she would have got if she had given only the principal amount to the borrower. So from the point of view of the lender, she is very much justified in asking for interest to be calculated on the accumulated interest as well. This scenario, where accumulated interest is also taken for calculating the interest for the subsequent period, is called a compound interest scenario. Let us look at this numerically, applying these principles to question Q2. Here the principal amount is rupees 10,000. Interest rate per annum is 10%, and the interest is calculated annually. A diagrammatic representation of the situation is given in the slide. The interest due at the end of 1 year term are indicated in blue, and the final amount due is indicated in red. First, let us look at the simple interest scheme. Here, the interest accumulated after year 1 will be 10% of 10,000 or rupees 1,000. Interest for the second year or the second 1 year period is again 10% of 10,000. Note that we are considering only the principal amount during the interest calculations. So, the interest after 2 years equals 1,000 for the first year plus 1,000 for the second year, or a total of 2,000 rupees. So under the simple interest scheme, amount to be given back to Sushma equals principal plus total interest, which is rupees 12,000. If it was a compound interest scheme, the computation will be as follows. The interest computation for the first term or the first 1 year remains the same as the simple interest case. That is, principal into interest rate, or 10% of 10,000, which is rupees 1,000. The deviation comes from then on. When we compute the interest for the second term or the second 1 year in this case, we add the interest accumulated in the first year to the principal amount, and the base amount used for computing the interest for the next term will be more than the original principal amount. So the interest for the second year period is calculated as 10% of principal plus accumulated interest for the first year, or 10% of 10,000 plus 1,000, or 10% of 11,000, which is 1,100 rupees. So, under the compound interest scheme, amount to be given back to Sushma equals principal plus total accumulated interest, which is 10,000 plus 1,000 plus 1,100, or rupees 12,100. The compound interest situation can be imagined in a different way also. Sushma gives the loan of rupees 10,000 to Rashmi for 2 years. Let us say Rashmi pays back Sushma a sum of rupees 11,000 after 1 year. That is, the principal rupees 10,000 plus 10% interest on the principal, which adds up to 11,000. Now Sushma lends this rupees 11,000 to Rashmi once again, and Rashmi pays back the 11,000 plus 10% of 11,000, or rupees 12,100 at the end of the second year. Note that an additional rupees 100 is earned by Sushma in the compound interest scheme when compared to the simple interest scenario. This is the interest on rupees 1,000, that is interest on the interest. In all real-world situations, compounding is the norm and simple interest calculations are mostly there only in the case of short-term borrowing and academic situations. Note that compound interest arises when interest is added to principal, so that from that moment onwards, the interest that has been added also earns interest. This addition of interest to the principal is called compounding. Now let us look how much the two schemes, simple interest and compound interest schemes, will differ if the duration of the loan is longer and the interest rate higher. Refer to the question Q3. We shall also use this example to learn an important formula for calculating compound interest. In the question given there, the person Kanju Rich is a money lender. Aman, the brother-in-law of Kanju Rich, takes a loan of rupees 1 lakh for a period of 4 years. On the same day, another person, Chaman, also takes a loan of rupees 1 lakh for 4 years itself. However, the interest schemes for Aman and Chaman are different. We are asked to find the difference in their repayment amounts. Let us see how to approach the question. First, let us look at what happens in the case of Aman, the brother-in-law, who got the loan on simple interest scheme. In a simple interest situation, the interest is calculated on the original principal amount only. Here the base on which the interest is calculated does not change, and the amount of interest earned during each period also does not change. An illustration of the situation is given in the slide. Interest for the first year equals principal rupees 1 lakh into the rate 0.2, which will be equal to rupees 20,000. Note that we converted the rate in percentage to decimal value by dividing it with 100. Interest for the second year is again the same, that is principal 1 lakh into rate 0.2, which is rupees 20,000. Interest for the third and fourth years will also be the same under the simple interest scheme. The total simple interest payable for the entire period can be found as P into R into N, where P is the principal amount borrowed, R is the rate in decimals, and N is the number of years. So the total interest due for the 4 years equals 1 lakh into 0.2 into 4, which is rupees 80,000. And so the amount that Aman has to repay to Kanju Rich at the end of 4 years equals the borrowed amount, which is the principal, plus the total interest, which is 1 lakh plus 80,000 or rupees 1 lakh 80,000. In the case of Chaman, Kanju Rich is following a compound interest scheme with interest compounded annually. In a compound interest scheme, interest is calculated on the original principal amount as well as on the accumulated interest. Here, the base on which interest is calculated increases with each period. The amount of interest earned also increases with each period. The timeline shown in the slide will help you understand it a bit more clearly. The interest for the first year is calculated on the principal. It will be the same as simple interest situation that we saw earlier. It will be equal to the principal 1 lakh into rate of interest 0.2, which will give us the value rupees 20,000. When it comes to the interest for the second 1-year term, the situation is different. Here the interest is to be calculated on the interest earned during the first 1-year term also. So as far as the interest for the second year goes, it would be 20% of the principal plus interest for the first year, or 0.2 into 1 lakh plus 20,000, which is rupees 24,000. The additional interest of rupees 4,000 earned in the second year when compared to the first year is the interest on the first year's interest. The compounding situation can be looked at as if Kanju Rich is collecting the interest amount for the first year and giving back that to Chaman as an additional loan, which also will earn the interest during the next year. Interest for the third year equals interest on principal plus interest on the accumulated interest. Accumulated interest equals interest for the first year plus interest for the second year, which is 20,000 plus 24,000 or 44,000 rupees. Thus the interest for the third year will be 20% of the principal 1 lakh plus 20% of the accumulated interest 44,000. This will add up to rupees 28,800. Interest for the fourth year equals interest on principal plus interest on the accumulated interest. Accumulated interest in this case will be interest for the first year plus interest for the second year plus interest for the third year, which will add up to rupees 72,800. Thus, the interest for the fourth year equals 20% of 1 lakh plus 20% of 72,800. It will come to rupees 34,560. Observe the increase in the base on which the interest is calculated with each period. The amount of interest earned also increases with each period. If we want to find straight away the amount due after multiple compounding, the formula given in the slide will be useful. The amount due under compound interest scheme is given by P into 1 plus R to the power n, where P is the principal amount borrowed, R is the rate of interest in decimals, and n is the number of years. Thus, in this case, the total amount due after 4 years will be the principal 1 lakh into 1 plus 0.2 to the power 4. When you do the calculation, you will get the value as rupees 2,07,360. This is the amount due after 4 years. If we want to find how much is the accumulated interest for the period, we will get it as total amount due minus the principal, which is 2,07,360 minus the principal 1 lakh, that is 1,07,360 will be the accumulated interest. Thus, when we compare the amounts paid by Chaman and Aman to Kanju Rich after 4 years, we can see that Chaman pays 27,360 more than Aman. This can be obtained by finding the difference of amounts paid back in the case of Aman and Chaman, or the difference of accumulated interests. Now look at the simple interest question given in the slide. It says that a particular sum of money will amount to rupees 12,600 in 4 years under simple interest scenario. The same amount will generate rupees 15,300 in 7 years under the same scheme of things. And we are asked to find the interest rate per annum that will facilitate this. Keep in mind that in a simple interest situation, the interest is calculated on the original principal amount only. Thus, the base on which interest is calculated does not change. And the amount of interest earned during each period also does not change. Here, we know that a particular amount, particular principal under the simple interest scheme at a particular rate of interest amounts to rupees 15,300 in 7 years and rupees 12,600 in 4 years. So the difference of the two amounts, that is 15,300 minus rupees 12,600 or rupees 2,700, will be the simple interest earned on the principal for the 3-year duration. In a simple interest scheme, as the interest earned during each period will be the same, we can say that simple interest earned for a year will be rupees 2,700, that is the interest earned for 3 years divided by 3 years, or rupees 900. It is known that after 4 years the amount due becomes rupees 12,600. This would be equal to the original principal plus the interest for 4 years. The interest earned for a 4-year period will be 4 years into the interest earned for 1 year, which is 4 into 900 or rupees 3,600. Thus, we can find the principal amount as rupees 12,600 minus rupees 3,600, or it will be rupees 9,000. Now we know that interest for a year equals principal into rate of interest. From this, we can find the rate of interest as rate of interest equals interest for a year by the principal amount. In our case, the interest for a year is rupees 900 and the principal amount is rupees 9,000. So the interest rate can be found out as 900 by 9,000, which is 0.1 in decimals or 10%. Look at the question given in the slide. Here, Bhavya is an extra long-term planner, and she has thought about her grandchild's future even at her young age of 25. She puts rupees 1 lakh in a scheme where it is compounded annually at 10% for the next 50 years. Let us see how much she will get after 50 years. Let us plug in the values to the formula given in the slide. P, the principal, is rupees 1 lakh. Rate of interest is 0.1 in decimal value. And the number of years is 50. On calculating, we can find that the 1 lakh rupees grows to a mind-boggling 1 crore 17 lakh rupees in 50 years. Now what if she had taken the money back in 25 years? Then it would have grown only to rupees 10 lakh 83,000. As you can see from this question, compounding, the process of adding interest to the principal, is a very powerful process. The effect of compounding depends on the periodic interest rate that is applied, and the impact becomes very high when the compounding is done for a larger number of years. Now let us look at another question to understand how the frequency of compounding affects the final amount. Look at the question Q6. In the question, we have the company taking a loan of rupees 10 lakh for a period of 1 year. We are asked to compare 3 scenarios: half-yearly compounding, quarterly compounding, and monthly compounding. The annual nominal interest rate is given as 12% in each case. Do not worry about the term annual nominal interest rate. When we simply say annual rate of interest, we are actually referring to this nominal interest rate. The period of compounding is less than a year in each of these cases. In such cases, we cannot take the annual interest rate to calculate the interest for the smaller period. To illustrate this, let us take the case of Bank A. The compounding or the addition of interest to the principal is done on a half-yearly basis here. If we take the interest rate for the period as 12%, we will get the interest as 10 lakhs into 0.12 or rupees 1,20,000. But 12%, that is rupees 12 per rupees 100, is the interest for a full year period. So it will be wrong if we take this as the interest for a half-year period. In order to avoid such errors, we shall use something called the periodic interest rate in cases where the compounding period is less than a year. Periodic rate is defined as the annual rate by number of such periods in a year. In the case of Bank A, the compounding is done on a half-yearly basis. So the periodic rate or the rate for 6-month period will be 12% by 2, which is 6%. In the case of Bank B, the compounding is done on a quarterly basis. So the periodic rate or the rate for the 3-month period will be 12% by 4, which is 3%. In the case of Bank C, the compounding is done every month. So the periodic rate or the rate for 1 month period will be 12% by 12, which is 1%. The slide gives an illustration of the half-yearly compounding of interest in the case of Bank A. Here, the interest accumulated at the end of 6 months is given by the principal 10 lakh into periodic rate 0.06 equals rupees 60,000. The 60,000 rupees is added to the principal amount, and the computation of interest for the next 6 months is done on the entire 10 lakh 60,000 rupees. So the interest for the next 6 months equals 10 lakh 60,000 into 0.06 or 63,600 rupees. So the total interest for the year equals 60,000 plus 63,600, which is 1,23,600. And the total amount for repayment will be principal plus total interest, which is 10 lakh plus 60,000 plus 63,600, or 11 lakh 23,600. The total amount due at the end of 1 year period can also be found directly by applying the formula as shown in the slide. When you apply the formula, note that the compounding is done twice a year and the rate of interest used for compounding should be the periodic rate, which is annual rate by 2 in this case. If we want to find the total accumulated interest in this case, that can be obtained by subtracting the principal amount of 10 lakhs from the amount due, rupees 11,23,600. As we had seen earlier, the accumulated interest will come to rupees 1,23,600 in the case of Bank A. In the case of Bank B, the compounding is done on a quarterly basis, that is 4 times in a year. The amount due after a year in such a case can be calculated directly using the formula given in the slide. A equals P into 1 plus R by 4 to the power of 4n. Here, P is the principal, R is the yearly rate of interest, and n is the number of years. In our question, the value of P is rupees 1 lakh, the value of R is 12, and the number of years is 1 year. On substituting the values, we'll find the amount due as 11,25,509 rupees. Accumulated interest in this case will be rupees 1,25,509. Please note that this is about 2,000 rupees more than the interest accumulated in the case of half-yearly compounding. And finally, in the case of Bank C, where the interest is compounded on a monthly basis, the compounding is done 12 times in a year. The amount due in this case is given by the formula A equals P into 1 plus R by 12 whole to the power of 12n, where P is the principal, R is the yearly rate in decimals, and n the number of years. Note that this is the same compound interest formula modified slightly to account for the multiple compounding within the year. The amount obtained on substituting the values is rupees 11,26,825. The interest accumulated in this case will be rupees 1,26,825. It is more than the interest in the case of half-yearly compounding and quarterly compounding. From these illustrations, we can see that it is better for the company to take the loan from Bank A where the computing is done on a half-yearly basis. If you recollect what we have covered in this discussion, you can see that we looked in detail the concept of interest, simple interest, and compound interest. The powerful idea of compounding was looked at from various angles. We also introduced you to some relations that will be useful in compound interest calculations under various conditions. The questions we discussed were all rich with concepts, and if you have doubt on any of these concepts, you should go through this presentation once again.